Before we can jump into characterizing a sustainable city versus an unsustainable one, on another level, scientists are still trying to define what a city is, with the understanding that once we understand what cities are and how they work and behave, we can begin defining what makes a city sustainable versus unsustainable. Perhaps one of the ways to define cities is to relate cities to things that we understand reasonably well, and by observing what they are, how they work, and what they do, we can conclude the same for cities to some extent. Some of the analogies that bring us closer to understanding cities include the following. Cities are like machines that can be optimized, and so in figuring out how gears in a machine are arranged so that we can make the machines work better, likewise, we can make cities function better by understanding their structure and components. Or cities are like insect colonies and social structure. So by observing how insects behave in their colonies, we can conclude something meaningful about how people behave in the wider organization of cities. Or cities are like river networks that flow and connect. And so by observing the meanderings of rivers and the hierarchy of rivers, streams, estuaries, and other water bodies, we can glean how cities and neighborhoods connect and how they are structured in a hierarchy of operations. Or cities are like ecosystems in biology. By understanding how they interact together, depend on one another, and grow in cycles and function in perfect unison, we can begin to see how activities and services in a city are interrelated in a complex network of networks that work together to serve the people that live there. And so CityLab picked up on the research coming out of the Santa Fe Institute on the science behind cities and highlighted that there is now scientific proof that cities are like nothing else in nature. This refers to the research by Louis Betancourt and his colleague Jeffrey West, who have been studying how cities scale, that is, how they grow. Part of what inspires their work is that cities is a rich topic, and people have thrown every analogy at it. But most of them fail somewhere, which keeps them working on discovering what cities really are. This realization was a result of knowing that we've always looked at cities by the way they look, by their form, and all along it was really about how they develop and how they change, so it was a process. It was about the function. The researchers claim that at their most fundamental, cities are not really agglomerations of people, they're agglomerations of connections between people. Betancourt is simply describing the interconnected relationships between the population growth of a city, the incremental expansion of the infrastructure networks that are required to meet people's demands, the socioeconomic outputs that result from our social interactions, and the density that develops in a way such that we benefit from ever more social connections without spending ever more energy to reach one another. Published in Science in 2013, Betancourt wrote about the origins of scaling of cities. With advances in data analysis and the ease by which data is collected and shared, we have better clues to the properties of cities. These observations across many disciplines are analyzed to show how different urban qualities and quantities like the length of road networks, the average income of inhabitants, and the number of patents per capita depend on the size of the city, which is typically measured by the size of its population. This particular image here is in Seattle, Washington, showing the growth of buildings and roadways. Betancourt concludes that cities are like a social reactor, and that they evolve according to a small set of basic principles. And for that to be scientific, it is important that these principles can be written in mathematical form. The empirical results also demonstrate that despite the apparent complexity of cities, they are actually quite simple. Betancourt found that all of these characteristics scale with city size. As population grows, so do all these other factors in amazingly predictable ways across world cities and throughout time. The graph here shows the log of the population on the x-axis and the log of the total road miles in the United States metropolitan areas on the y-axis, based on data for 415 urban areas which were obtained from the Office of Highway Policy Information from the Federal Highway Administration. The red line shows the best fit line to a scaling relationship. The yellow line is relative to the theoretical prediction, and the black line is the linear scaling. You can see that new infrastructure grows slower than population. The graph here shows again the log of the population on the x-axis and the log of the gross domestic product, the GDP, in US dollars on the y-axis, based on data obtained for 363 metropolitan areas in the United States from the US Bureau of Economic Analysis. Like the previous graph, the red line is the line of best fit to data, the yellow line is the theoretical prediction, and the black line is the linear or proportional scaling. You can see that GDP grows faster than population. Reflecting on Betancourt's analysis, his framework suggests that there exists an optimal city which has the most optimal social interaction and optimal social and economic output with the least cost of connecting people and goods and services to each other. For example, a sprawled city isn't reaching its full potential and could achieve that if more people moved into town in denser development. Similarly, a densely populated but congested city loses its potential and perhaps could do better with better transportation. The idea that cities are governed by some rules of math may make it sound like the planners and the engineers have little control, whereas in fact they are in control of steering cities towards an optimal point that makes the city efficient, or in other words, sustainable. The graph here shows values of G, a variable indicating the social interactions in a city on the x-axis, and on the y-axis we have social benefits minus costs. These are the costs of developing this infrastructure that makes these interactions possible. There's a minimum point G, shown on the graph as G min, the circle on the left, and a maximum point G, shown on the graph as G max, the circle on the right. There's an optimal value of G, shown on the graph as the green circle labeled as G star, at which cities are most productive and corresponds to the most efficient city. Cities can exist when social interactions are positive, that is, the G is more than the minimum point G min and less than the upper value of G, which is G max, at which point the dissipation costs overcome benefits. Beyond that optimal point, the number of social interactions in a city can still grow, but the cost of them rises faster than the benefits. What an interesting way of measuring that growth and demonstrating mathematically the sustainable growth in cities. Ideally, as cities grow, this mathematical visual means that they should become even more productive and even more powerful. And in this way, Betancourt has an analogy from nature that works for the time being, and I quote, "As stars compress matter, they burn brighter and faster the bigger they are, but stars can eventually run out of energy. They're not open-ended, and they're isolated systems where cities rely on food and other resources from beyond their borders. Cities are part star, part network." End of quote. Hence the social reactor description for cities that was mentioned earlier. In The Science of Cities, Michael Batty studies the details of what happens when cities grow, which offers insight into why some cities function better than others of the same size. And relative to Betancourt's work, he says that this theory explains why big cities generate more income and creativity than small cities do. Michael Batty says that the simplest way of thinking about it is that if you think about all the connections you can make in a city, it's population squared. So if there are 10 people, there are 100 possible links, and if there are 100 people, it's possible to make 10,000 links. We can't realize all of those links and networks, but generally speaking, big cities give opportunities for more contact. I think we're ready to explore what makes a city sustainable and contrasting it by taking a look at a few definitions of sustainability attempted by some authors. What does the dictionary say? Sustainability is the quality of not being harmful to the environment or depleting natural resources, and thereby supporting long-term ecological balance. Notice the emphasis on the environment and resources and the balance, not just now or in a certain time frame, but long term. The origin of the word sustainability was first founded in 1972 in its general sense in the areas of economics, agriculture, and ecology, and historically it was defined as a requirement of our generation to manage the resource base such that the average quality of life that we ensure ourselves can potentially be shared by all future generations, and that development is sustainable if it involves a non-decreasing average quality of life. This is as cited by the World Bank in 1994, but sustainable development has its own definition that was established earlier. Here's the well-established definition for sustainable development. This definition was first identified in a report by the World Commission on Environment and Development in 1987, also known as the Brundtland Commission, and reads as, "Sustainable development is development that meets the needs of the present without compromising the ability of future generations to meet their own needs." Notice the emphasis on the present and the future, and emphasis on needs. Here's another definition for sustainable development by Goodland and Daly in 1996. Sustainable development is development without growth in throughput of matter and energy beyond regenerative and absorptive capacities. Notice the actions of regeneration and absorption, which refers to waste assimilation, and as a whole refers to the biosphere's capacity to do both. Sometimes, it's easier to define something by observing what it is not. To define an unsustainable city, Moavenzadeh, Hanaki, and Bacchini defined it as follows. As the 21st century dawns, megacities, great and far-reaching concentrations of power and influence, have become centers of the phenomena of globalization and information exchange. These concentrations of people and activity are placing stress on the natural environment so great that it is beginning to have extensive regional and even global impacts. And by way of contrast, a sustainable city is one in which its people and businesses continuously endeavor to improve their natural, built, and cultural environments at neighborhood and regional levels, whilst working in ways which always support the goal of global sustainable development. This was by Houghton and Hunter. These definitions reflect on the meanings of sustainability and sustainable development and sustainable versus unsustainable cities. And we all have our thoughts on the meaning of that word as it applies to cities and its interpretation of activities in cities and its manifestations of a city forms and functions.